Welcome to Photon Tutorial's Life Science Lab. I'm Wendy, an application scientist, and I'll be presenting our IR VIVO, a benchtop preclinical imager to look into mice in the infrared. Using the near-to window has a lot of advantages. As you can see in the graphs beside, there's a lot less scattering, less fluorescence, and also less absorption. And all these factors combined together, you can achieve a higher spatial resolution, a higher contrast, and also a higher penetration depth that is up to 10 times more than in the visible region. For the purpose of this guided tour, we have altered the door so we can see what's happening inside even though it's open. Basically, the system is an infrared camera with some optics, an illumination module, a filter wheel, and a motorized stage to put the animal in a light-tight box. First, the illumination module can have 1 to 4 different wavelengths. In this system, we have 760, 808, 890, and 940 nanometers. We also have a filter wheel that can hold up to 12 different filters, band pass or long pass. Our team of experts can help you find the right configuration. So once the light hits the markers in the mouse, it emits fluorescence and it goes back to our lens system. The way we designed our lens system has a focal length of 30 millimeters and an aperture of 1.4. What's nice is that you don't have to worry about being on focus or not. We have designed an automatic motorized focus, so you always stay in focus. We designed the system to be customizable on every part to fit all kinds of needs. For example, the animal stage can be fixed or motorized on the 3 axes X, Y, and Z. So the wider field of view possible is 15.6 by 12.5 centimeter, and the smallest field of view possible is 5 by 4 centimeters. For the lenses options, you have 3 different choices. The first one is a wide lens meant to see 3 mice at the same time. The second option is a macro lens to have a field of view for 1 mouse. And the third and the nicest option is to have both of them to see 3 mice at the same time, and also have the options to zoom in a specific organ of the mouse, for example, the brain. The light is directed to our high-speed camera, the Alizé 1.7X, which is also a product from Photon, etc. It is cooled down to minus 50 degrees, and it has a spectral range of 500 to 1600 nanometers. What's cool is that we can have a live view even though we are not recording a video now. Have a look. You can have 2 different accessories with the IR VIVO. The first one is the anesthesia system that's coupled to a nose cone. If you have yours, we can simply integrate yours. And the second accessory is the spectral probe inside the system. It's meant to extract a spectrum from a specific part of the mouse in real time. So all that being said, let me show you how quickly and easy it is to take an acquisition with the IR VIVO. I have a sample here of ICG in a cuvette. ICG is known to have a good emission tail in the near-to region. So I'm just going to place it in the system, and you can see it live without recording the video. As I close the door, the image disappears on the live view because it's light tight. I need to enable the LED mirror source to view the broadband image. Then, to capture the fluorescence, we need to set a filter matching the laser. In this case, ICG works best with an 808 laser, so I chose the filter accordingly. Then I'm selecting the 808 laser, and as soon as I enable it, I get to see the fluorescence very clearly in real time. To optimize the dynamic range of the camera, I will increase the exposure time to 5 milliseconds. All the parameters are now set for an acquisition. So I will stop the live view, disable the laser, and click on the ICG Near To button to launch a sequence of operations. This sequence is pre-programmed to simply capture broadband and fluorescent images accordingly to the settings we first chose. Many sequences can be made to accomplish various operations from simple image acquisitions to temporal analysis. Now, I will create the final image by overlaying the fluorescent image over the broadband one. Let's set the color map to green to match the ICG. Finally, we can adjust the overlay threshold to set the desired level of intensity. This way, you could visualize the fluorescence of ICG superimposed over the image of the injected mouse. Near-to fluorescence imaging enables new applications because we can see deeper and smaller features with a high degree of clarity. Some applications include drug biodistribution, tumor detections, or cell environment assessments, and also monitoring microvascularization, heart rate, and blood flow, and many more. If you're interested in knowing more, you can contact us at sales@photonetc.com.